Hello Hambini fans and welcome. In today's episode we have something a little bit different. An individual has sent me in a bicycle frame. Now to give you a little insight into what this is all about, someone who's one of my followers bought a Hambini bottom bracket, which is here, and then managed to get it stuck. Now this chap works in a bike shop and he bought this frame, and to all intents and purposes it's brand new. When he got it stuck, he tried to get it out and obviously couldn't. So that's when I got involved. Now normally, one of the non-advertised services that I offer is quite a lot of bicycle teams send in their frames to have custom bottom brackets made. And the reasoning for custom bottom brackets is they're in search of marginal gains. One of the biggest marginal gains is the friction inside the bearing and the attributed misalignment from that. Now, to give you a bit of background about this frame, this is a Tifosi frame. Tifosi might sound Italian, but they're actually based in Leighton Buzzard in the UK, and they are the I guess the house brand of one of the big UK distributors called Chicken Cycle Kit. So the frame is BB86 and it's carbon bodied. I don't think it's of monocoque construction. It looks like it's individual segments that have been glued together. Now a lot of people tune into this channel for the raw engineering, and I have quite a lot of people who are at university and riding their bikes tune in to find out what the hell I do and how the hell I mess up all the time. Anyway, so the first thing to do is to make sure that the dimensions that you can check, that you are responsible for, are accurate. So that is the bottom bracket. Now I've checked these as best I can with a vernier and also a micrometer. I can check that diameter with a micrometer. This one nearer the bike frame could only get a vernier in there, and they appear to be okay. Now the guy that trained me, he said fairly early on in my training, he said, assume everyone is a fucking imbecile until proven otherwise. And this advice is sound advice. So what you have to do is you have to assume that whoever's made this bike frame hasn't done their job properly. Now the most obvious thing to check is the diameter on the other side. So let's do that. So here's the non-drive side of the bike frame. Now this is a bit of a dodge because I've already checked this with a micrometer, but with a micrometer I can't show you the exact value. Now it's supposed to be just under 41 millimeters, so something like 40.95 to 41. Now if we check this, again, vernier isn't one that I would recommend for checking if you're a professional, but if you're just trying to give yourself an idealized figure, then not so bad. So if we check this, I'm just trying to get it in the shot. Oh god, there we go. That is around 40.89, and if I press really hard, 40.9. So it is, or 40.92. So it is well undersized. So that's in one plane. If I check again on this plane, and bear in mind you're not going to be able to see this, it is 40.88. So the hole is oval. Now because the frame is so undersized and the micrometer readings actually came out at 40.90 and 40.88, this I'm not sure how the chaps got that bottom bracket in without snapping the frame, because that level of interference is massive. So what I've done is I've sent this to be UT checked. So UT is ultrasonically checked to check for any cracks, and it's come back completely clear. Now the next obstacle is to get this out. The sort of barbaric way will be to slash it out, but I don't really want to do that because I want to save the bottom bracket for the chappie if it's possible. So another way is, I guess, the standard removal method, which is just to pull it out. Now, in order to facilitate pulling this out, what I'm going to do is I'm going to cool the bottom bracket and then heat the carbon fibre frame. So what I've done is I have heated all the way around the frame with a hairdryer, and this is just compressed air. So compressed air at 10 bar, once the pressure drops, it loses temperature, so we can cool the aluminium quite rapidly. Now this works because the thermal conductivity of carbon fibre is much worse than aluminium. So the aluminium is actually extremely cold. Now I've made a little clamp here to go round this. So if we put this round, it's just so that the forces are distributed and it doesn't splay this chap's bike frame, because I'm not confident that this frame and the tolerances involved are all that good. So we're just going to put this bracing piece round it. So I've machined that up like that. Now we're ready to pull it out. In order to pull this out, just use a standard removal tool. So it's the standard removal tools that I supply. That goes over there, that goes in the other end, and then we just pull. So let's try that. Okay, so it's located. We just pull up on here and then feel it engage. Spin this down. And it should start to pull out. Oh. So what's happening now is the nut on the other side is turning, so we're just going to stop it from turning. And then the bottom bracket has been removed. So we got the bottom bracket out. The next thing I'm going to do is scan this, but just as a check before I go and scan it, I measured this side of the bottom bracket. Again, I did use a micrometer, but this came out undersized as well. I don't know if you can see that, but that's 40.9, and I got 40.88 with a micrometer. So what I've done is I've done a few slides and things to show you how we got on with the scan, but just as a starter, this is the Tifosi website, and this is Chicken Cycle Kit, who I've just highlighted at the bottom, and they are the distributors for them. The stuff that it has on their website, all of this kind of stuff, if we hit about, there's some stuff about how Tifosi came about and all that kind of stuff. These are the teams that they sponsor. I think they're fairly big teams. I don't really follow bicycle racing. I don't really have a desire to. But anyway, what I've done is I've done a few slides about what happened in the scan. So if I play them, hopefully this will work. Yeah, so this is just a few slides that I've done. In case you're tuning in and wondering who the hell is this guy, this is the scan result. So let's hop to the SolidWorks file. So the SolidWorks file, if I load it up, this is the SolidWorks file, and it shows. Well, I've only done half the dimensions, but you know, quadrant dimensions. But basically, the bottom bracket on both sides is slightly oval, but more of a problem is this 0.56 at 14 degrees, and that's parallel misalignment. We'll come to that in a second. If I go back to here, right, I've just said that. Right, I also had it ultrasonically checked. So a company called TUV, TUV, they go and ultrasonically check, a bit like Lucia Technic does. Well, it's the same way that Lucia Technic does. So they're checking for cracks, any delamination internally and all that kind of good stuff. Didn't find anything. So geometrically, I think I've really covered this, but if I can turn this laser pointer on. Oh yeah, that's better. Angular misalignment was very low, almost zero. The bottom bracket face was irregular. Parallel misalignment, like 0.5 millimetre, is freaking massive. It's really quite high. And the fit tolerance was utterly freaking crap. Utterly shite. Now, on the previous picture where I showed you the... how do I get off this? Right, the SolidWorks file here. These dimensions don't really correspond exactly to what I had with the micrometer, and I would go by the micrometer as opposed to Faro arm. I think there's more error in the Faro arm in terms of ultimate dimension, but the misalignment dimension is fairly good. It's just the way the Faro arm checks it, because you're checking a point rather than I guess a bigger diameter. If we go back to this, right, can I just click right. Performance implication. So if this chap had run his bike with the bottom bracket as it was, the L10 life, which is a standard calculation for calculating bearing life, will be down by 75%. So you'd only get 25% of the normal life. The power loss at 35 kilometers per hour is around 4 watts, so that's a lot, and that's mainly from the misalignment, and the bearings are trying to sort of wiggle around to align themselves as they go around. It's not really all that easy, and there's a high likelihood of creaking or fretting. So I mean, when that frame turned up and I tried to spin the bearings, the bearing that was captive, I couldn't even turn it. It was just like almost ratcheting round. It was horrible. Right, so the problems, the fit that I said was utterly shite is fairly straightforward to fix. The parallel misalignment is much more of a problem. So maximum parallel misalignment is 0.2 millimeters, and that is being charitable, to be blunt. Less than 0.05 is what you should aim for. So that's 0. So it's 4 times the amount. In the case of this bike, it's 11 times what it should be. And then yeah, fixing parallel misalignment is technically challenging. To talk about how parallel misalignment works, what I've done, well, there's this drawing here on my website. You can go and zoom in if you want, but here's a zoomed in copy. So this is, let's assume, the fixed bearing on the drive side. This is the bearing on the non-drive side, and these black lines represent the center line. Ideally, you want the black lines to cross, or to be completely like an extension of one another. But they are offset, and that offset causes this drag, which is problematic. So, possible solutions. Well, you could have a split bottom bracket and then live with the misalignment. So most of my bottom brackets are one piece, but the the industry standard, I guess the vast majority of them use 2 pieces or 3 pieces, so one on the drive side, one on the non-drive side, and a sleeve in between. It's not really that stiff. It doesn't help you with alignment, but if you have like objects like Di2 boxes and that sort of thing, it's not a problem. Another way is I could have used a standard Hambini BB and then machine the outside down to cope with the fit. It isn't a perfect solution, but it would do the job. And the misalignment would probably be within the nominal range. All you're doing is you're just trying to manipulate the bike frame so it fits. Yes. Another way is into the frame you could insert a single piece of metal and then bore it from either side. The problem with that is the jigs and things to hold the bike frame, and they would be bike specific. And the datum, so where do you get your datum from? And you actually have to machine it in sort of an S shape to get it to work, so it's not straightforward. You could CNC an S-shaped bottom bracket. Now CNC is like the in-word, computer numerically controlled, or computer numeric control, I don't know. And people rave on about this, and in my line of work you would think that I would be championing this all the time, but I found, and the people I work with have found, that when you get to thin-walled metal structures, and a bottom bracket is a thin-wall metal structures, as you try and machine into the surface, it behaves a bit like, well, it's like trying to machine paper. So as you machine paper, it deflects. I guess the best way to describe it would be like trying to cut a loaf of bread. As you bring the knife in, the initial sort of knifing action causes the bread to compress before you make the cut. And the same thing happens with aluminium and alloys that are thin wall, even steel. So there's too much flex. Now people will say, oh, Hambini, you could use a mandrel. Yes, you could use a mandrel, but I'd have to have multiple mandrels, and the prattling around will be a right pain in the rear end. And if you're using a mandrel, what's the point of having CNC? Because it's setting it up is just a pain. Another way is to machine an eccentric bottom bracket, and yes, we will come to this in a minute, but it's technically difficult to make. It's extremely difficult to make. And the final one is to buy a Kogel bottom bracket. Now, a lot of people say, Hambini, you should not be slagging other people off. Well, I wouldn't have to slag people off if they didn't bullshit all the time. So this is what Kogel said. So Kogel asked this question on Bike Rumor. So if I bring show the taskbar, they asked this. So someone asked all of this stuff. So I've just copied it verbatim from there and put it here. Basically, Kogel said if you buy one of their bottom brackets, it will work within a range of 0.2 plus or minus the nominal diameter. This is complete and utter bullshit. Absolute bullshit of the highest order. So they're saying their bottom bracket will work with this chap's bike from 40.8 all the way to 41.2. Now, NTN, SKF, NSK all said the range is 0.02 to 0.04 interference. Kogel have said it's minus 0.2 to 0.2. To give you an indication of this, this is one of my removal tools that I use to fish bearings out with. And if you go on my website, you can buy one of these things. It's typically for BB30 bearings or 6805 bearings or 6806. This has got a 0.1 millimeter clearance in, so it's a quarter of the range that Kogel say they'll work. So this is 0.1. Put it in. Can you hear it rattle? That's a rattling good fit. Absolutely extraordinary what they've said. Complete bullshit, and I'll call them out and say they are a bunch of liars. So if they want to send me a bottom bracket, and I will machine up a precision minus 0.2 and plus 0.2mm bottom bracket, and we can see if it works. Bullshit of the highest order. It drives me up the wall. Anyway, let's move on. Right, this was the fix. So I machined an eccentric bottom bracket. Keeps the bearings parallel, but it does require a timing mark because one side is more offset than the other. It is technically complicated to machine this because I'm going to show you why. So this is a normal bottom bracket. So you've got the drive side and the non-drive side and the sort of center section in between. This is the schematic of the Tifosi bottom bracket. Okay, it's exaggerated, but you can see that the one side, in this case the non-drive side, is completely offset. So to machine that is a pain in the rear end. Then we go on to the little tit bits. Now the tit bits are this stuff. So choice of bearing, normally I would go with NTN, but the running clearance in this case will be tight. So in the end I went with NSK 6805s, class 6 to keep the cost down, and VV seals. And then the fit, now I calculated the fit with I verified it with FEA. But what you can do is you can use a hoop stress calculation. So the hoop stress is normally you use it for thin wall pressure vessels, but instead of using pressure you can use the stress generated by the interference times D, which in this case is 41mm, or 41 times 10 to the minus 3 meters, divided by 2 times the wall thickness, and that'll give you the hoop stress. One of the schoolboy errors that you could do, and I've done them in the past, is you can mess up the strength of carbon fibre. Carbon fibre is strong, but it's only strong in one direction. It's strong in tension, but in compression it's not that strong. And if you have the fibres in the wrong direction, it's not that strong. Now, what I mean by that is, if for example you take a plastic bag, and plastic bags are quite a hard thing to come by in the UK since they started charging people for them. If you take a plastic bag, it's actually, the fibres run that way, so they're quite strong. But if you pull it across this way, it stretches quite easily. And the same thing happens with carbon. So what they do is they get lots of these layers and then orient them at 45 degrees, 30 degrees, 15 degrees to build it up, to give you the strength. But when it's around a hoop, so around in a circle, you've got stresses that are acting radially. So if you go on the internet and then look up what is the yield stress of carbon fibre, it'll tell you what it is in pure tension. In like a radial sense, the limit that I use is 60 megapascals. Now, going on to what I was saying before about assuming everyone is an imbecile, the guy, my materials guy, is someone I've known for a long time, and he has been proven otherwise, and he's not an imbecile. So he said 60, use 60. So that's what I've gone with. So what I've done now is I've cleaned the frame up. So there's a few burrs in there, some sort of carbon sort of deposits and fragments and rough bits, and I've cleaned them up with some very fine emery paper. Next job is to spray a bit of activator into the hole. And then we need to leave it for a little while. I'm just going to wipe this off right now. This is the new bottom bracket. It looks just like the one that came out, but it's been machined to cope with the fit issue and also the misalignment. What I've done is I've made a very small mark on the frame and a corresponding mark on the bottom bracket. You probably can't see them, but they're alignment marks, so we get the positioning absolutely bob on. The activator's gone off now, so we can install this. The standard install pieces are just as you would get with a normal Hambini bottom bracket. but I've modified the alignment tool on the other side. So let's start installing that right now. So I've set up the press. I've used a nut on the other end as opposed to a normal handle, but it's only for photographic purposes. The bottom bracket's ready, everything's got to go, we just start to push. It'll go slack when it goes halfway down. It's gone slack, so it's half in. At this point we need to apply some retaining compound on that surface and the corresponding surface on the other side. So let's do that. Okay, now the key point is the alignment mark. So I've got an alignment mark on the frame and an alignment mark on the bottom bracket. We just need to make sure they all line up. So what I've done here is I've just literally turned the bike over so it's easy to photograph. The bottom bracket's halfway in. I've applied a bit more retaining compound onto that side, and this side already has a retaining compound that you can see. This is one of my presses, so all we're going to do is press it. This is the alignment tool on the other side. So we insert that, put that through. There's a mark on the frame and a mark on the bottom bracket which you can't see. They're here and here, and I'm just going to make sure that they line up so we've got the misalignment corrected. Now that's gone firm. I'm just going to get a feeler gauge and just check round here. You can already see there's a small gap. So this is a 0.05 feeler gauge, which is 2/1000 of an inch. There's a small gap there, big gap there, but nothing there. So that tells you the frame is not perfectly square, but we knew that anyway. That's actually pretty poor. We need to give this a little test. So what I've got is I've got the original cups. Put that in, and here is a spare crank that I've got. It's a Dura-Ace crank, so we'll slide that in. Put the arm on the other side, flick that down, and we'll just screw that in hand tight. All we're doing now is we're checking for misalignment. Misalignment manifests itself in a spin test, so bottom brackets that are poorly aligned won't spin very well. So that's actually pretty good, so there's a job well done. So that's really quite good, I'm quite pleased with that. Close up of the non-drive side of the frame. So I've just cleaned it up and you can see it's come through. It's quite a neat job. And this is the drive side. Again, it's fitted fairly well. And also hopefully just about seam mark. So they're aligned very, very closely. And that's about it. So there are a few things to take away from this video. I guess the most important one is if the bottom bracket gets too tight, please stop. In terms of the frame, this frame, the manufacturing quality on it to the eye looks really good, but the scans and the trouble that this bottom bracket has caused is quite significant. This would normally be a frame where you would just push in Delrin cups, put the bearings in, and you would have extremely poor life from this. The brand manufacturer Tifosi, would I recommend them? Well, on the grounds of this effort, definitely not. I mean, if they want to respond in the bottom of the comments box, then they are more than welcome to do so. If you've got any comments, please write in the comments box below, or if you've got a bit more of a technical query, please send me an email, check out my website, it's www.hambini.com, and that's it. Thank you very much for watching. If you liked, please hit that subscribe button and hit the like button, and that's it until next time.